Good evening. Thank you so much for joining us for the second of our CPD sessions, this time in mathematics. We are absolutely delighted to welcome Paul Burrows of Vine Hall School, and he is one of our maths setters. He will be speaking to you tonight about all sorts of things to support you in delivering the second year of teaching the new specifications for CE. And tonight we're going to focus on exploring how the CE 13 plus maths spec can encourage problem-solving skills across the whole curriculum. So this is really looking at the way in which maths can also support your students with those wider interdisciplinary skills as well. And CE can really come to life in that way in your school. This webinar comes as a sequel to the previous Twilight CPD session on maths in March, where with Patrick, we reflected on year one and discussed preparing for year two of teaching the new maths specifications. I really hope you enjoyed this session with Paul. And let me also remind you to join us on social media. We are at ISEB Awards on all channels, so come and say hello. Once this session has finished, there will be time for questions. So please use the chat function in YouTube to submit those to the live stream. Now, if you can't see the chat function, it might be because you're not logged in. Either log into YouTube or Google if you have a Gmail account, or if you have a Google account or a YouTube in any way. If not, you may need to register for one. And what that will do is that will help you unlock that chat function. You can send us questions at any time. Sophie, backstage there, is going to collate them for us, and then Paul and I will have a chat afterwards where we can answer all of those questions for you. I've also got some that some of you kindly sent in beforehand, so thanks for being so organised. But without any further ado, let me hand you over to the brilliant Paul Burrows.
Hello. This is slightly odd in that I know that everyone can see me, but I can't see anyone at all. I will give you just a little bit of background on myself before we get going. So I'm Deputy Head of Vine Hall. I've been working with ISEB for quite a few years now. Originally, I was with the 11 plus team, so I'm now the 11 plus team leader, overseeing those papers. I am also on the 13 plus team, and I have specific responsibility for the new mental arithmetic papers. And I was also involved in the drafting of the new specification for 13 plus. As well as working with ICB, I've worked with IPS. I was maths subject advisor for a few years. That was a couple of years ago. And in that role, I had the dubious honour of addressing about 80 or so prep school heads at the IPS annual conference a couple of years ago, before COVID hit. So in terms of what we're kind of focused on in this session, I mean, I'm not going to go into too much detail about kind of the changes that have been made. Hopefully you've seen all the documentation that ICB have produced about, what's in and what's out and what's changed, and some of the rationale for that changes as well. I'm going to focus a little bit more on the kind of a certain specific elements, I suppose. So one of the things that when we first sat down and looked at the 13 plus papers kind of as they were and started making decisions about what changes we would make, the big barrier that we hit first was not the content of the questions, but really the style of the questions. It was felt that they were too wordy a lot of the time. There was a lot of context that felt kind of highly contrived. We wanted to, I guess, strip back a lot of that to allow children to kind of get at the maths a little bit more readily. So if you've seen the specification papers, you'll see that there's not that you've got kind of more bare arithmetic, if you like, and there's much less scaffolding in those lengthier questions. So kind of rather than holding the pupils' hands through the questions, it's kind of, here's the question, and we're going to leave you to kind of work it out however you kind of see fit, if you like. The straight line graphs question is possibly the best example of that. So rather than sort of the tables and all the other kind of paraphernalia that went around those questions, we've now got just to draw this graph and leave them to kind of do it as they've been taught, or as suits them. I guess the other side of it was alongside that, and part of that is this idea of kind of focusing more on a problem-solving approach, so opening those questions up more, so it isn't quite so much scaffolded, and actually giving them the opportunity to hopefully develop those problem-solving skills and apply them within the paper. So at the moment I can't see any slides, so I'm hoping you can see some slides. There we go, there's the first one, perfect. Okay, so I will get you to do a bit of maths as we go along. This is my first question for you. I'll give you a minute or so to think about. Well, I'll read it through. Vinehall prison, 100 prisoners in cells numbered 1 to 100, also 100 guards. The first guard turns the key in every lock to open every cell. The second guard turns the key in every cell, which is a multiple of 2, locking all the even-numbered cells. The third turns the key in every cell, which is a multiple of 3, locking or unlocking them. Fourth guard, every multiple of 4, locking or unlocking them, until the 100 guards have kind of gone through that process. So which prisoners will be set free, and why is it that those particular prisoners are set free? And you can throw your ideas into the chat. Now, either everyone has kind of got a piece of pen. I should have said to begin with, you're going to need a pencil and a piece of paper for this session, so you can scribble things down. And either right now, everyone is kind of busily trying to do some maths, or they're checking their emails while someone else does the maths for them, and hoping that someone else puts the answer into the chat, so that they don't have to. I would say with the setup of the question, it's quite hard to do on a webinar, but if I was in class, I'd have the 10 children sitting at the front on chairs, and then I'd have the other children working as the guards, so that we could establish who was waiting, who was coming out, and who was getting set free and who wasn't. Okay, I haven't got any volunteers for answers. It's just like I've got a year 7 group at the moment who kind of all sit there silently and don't say anything to me. I kind of feel like I'm back in that class again. So, well, we'll come back to kind of what this problem illustrates in a second. So if we move on to the next slide, and I'll talk a little bit about problem solving generally. So this is there's a famous book by a Hungarian mathematician called George Polya called How to Solve It, which wrote in the 50s, in which he kind of set out or tried to set out like a problem solving heuristic, where he identifies the steps that you need to take in order to solve a mathematical problem. And there's basically, so he breaks it down to 4 steps. So we go on to the next slide. That's the first of those. So first of all, you have to understand the problem. Next slide. And go on to the next one. You have to devise some sort of plan for kind of actually solving it. And then if you go on to the next slide, we've got the kind of carrying out of that plan, and then looking back and checking the result. Now, on face value, this starts to look a little bit like what you quite often see on school classroom walls or maths classroom walls. If we go on to the next one, this kind of rucksack acronym type thing, which says you should read the problem, understand the problem, choose the strategy, solve the problem, answer it. Not quite sure how those 2 things are distinct. So Darren's just asked if we'll get the PowerPoint. I'm hoping the answer to that is yes. Yeah, I think it all becomes available after the webinar's finished. think someone from ISEB will tell us very soon whether or not you get them afterwards, and then you check it. But there are kind of fundamental differences between Polya and this kind of poster that you frequently see. But in order to kind of really appreciate those differences, the first thing you almost have to do is kind of take a step back and understand what I guess what makes a mathematical problem somehow different from other types of maths questions. So if you go on to the next slide. So this is what the national curriculum has to say about problem solving. National Curriculum for Mathematics aims to ensure that all pupils can solve problems by applying their mathematics to a variety of routine and non-routine problems with increasing sophistication, including breaking down problems into a series of simpler steps and persevering in seeking solutions. I don't have too much of a problem with most of that. I would argue that you can't have a routine problem. If something is routine, then it's not really a problem. So there's something in there that doesn't quite make sense, but it was put together by Whitehall, so that's not altogether surprising. Polya's approach is very straightforward. Where there is no difficulty, there is no problem. And then kind of developing that idea is this final one. A problem is only a problem when the solution or the means of reaching the solution are not immediately apparent. That is, when what to do is not self-evident and one must apply oneself to discovering the path that will lead to the solution. Now, a simpler way of saying that is on the next slide, which is that basically a problem in maths is only a problem if you get stuck. And that's almost the kind of what defines a mathematical problem from anything else. Is if it's immediately apparent what you've got to do, then it's not a problem, it's just a question. Whereas for it to be a problem, you have to get stuck first. And you could be stuck because you can't see how to get from the question to the answer, or you could be stuck because you don't really understand what the question is asking you. So this is my other favorite book on problem solving, called Thinking Mathematically. I think this one's from the 80s, and it has lots of fun pictures of people with beards and togas, because obviously that's what you need when you're writing a book about problem solving in maths. But there's a great line here. It is an honourable and positive state from which much can be learned. I like that quote for kind of it's helping to explain to children that actually the whole point is that you're supposed to get stuck. And I suppose it's especially the case when you've got children asking for help in a lesson, and actually the problem is if you lead them through the problem, then you're reducing the problem to just like an addition or just to some other kind of mathematical operation. And actually the whole point is that you need to get them to that point themselves. And if you help them, then all you've done is reduce that question to a multiplication. And you knew they could do the multiplication anyway. So there's no real point in you kind of helping them too much. So you can just turn around and say, don't worry if you're stuck. It's an honourable and positive state to be in, and I'm not going to help you get out of it, because it's much more satisfying if you get out of it on your own. And this is really where Polya comes in, I suppose, and what differentiates Polya from the kind of the rucksack acronym is it's the devil's in the detail. And actually what Polya gives you is how you get unstuck. The rucksack says you have to read the problem and understand it, but it doesn't tell you what to do if you don't understand it, or if you've read it and it doesn't make sense. And actually what you need Polya for is for the kind of those, what are the options here? I'm now stuck. How do I now become unstuck? And I think teaching problem solving and is well, from my point of view, is probably the hardest part of teaching maths. And we've made it, or we're trying to make it a much more integral part of the ISEB syllabus and the common entrance papers. And that's kind of the reason then behind this webinar is to we've put this into the papers, or we're trying to put this into the papers, and therefore it makes sense to kind of talk about how then you can help children prepare for papers that are going to be more slightly more open in their style of question. And this also then and it does then follow into GCSE. You know, the GCSE specifications were changed a few years ago as well, and you know, it's much harder now to say with any certainty that, you know, a child's going to get a 9 rather than 8, because there is that greater emphasis on problem solving. And problem solving is, you know, it's just that much less predictable than you know, straightforward kind of typical questions, if you like. If you go on to the next slide for me. So Polly has all these ideas about all these different kind of strategies and approaches that might help you to solve a problem. And so what I want to do today is kind of look at those in a little bit more detail. And then I guess what I would hope to achieve in my classroom is that, you know, over the course of 2 years, and more so in year 8, I suppose, that they begin to kind of become familiar with these strategies themselves, and therefore can learn when to apply them. They learn when a particular strategy is going to help them get them unstuck, if you like. So one of the things that Polly suggests is that you imagine a more accessible related problem, or in other words, simplify it, and then look for some kind of pattern. So I don't know if any of you are still playing with the prison cell problem, but if you look at those, if you focus on those first 10 children who are imprisoned, and who's going to be set free and who's going to remain in prison, what you find out is that the ones that get set free are the ones in cell number 1, cell number 4, and cell number 9. And then you get onto the kind of the next step of having simplified the problem is to look for some sort of pattern here. So you've got the numbers 1, 4, 9 in front of you, and you're, you know, in the classroom, you're obviously then saying, well, what do you think is going to come next and why? Who's going to be the next person to set free? And can they kind of justify and explain that? And hopefully they recognize that as their, you know, that's a sequence of square numbers, and you know, and then kind of come around to why is it that those numbers are, why is it that the children in the cells that are the square numbers get set free, and you know, the fact it's that those are the numbers with an odd number of factors. So this is, I would use that particular problem when I'm introducing a topic on properties of number, because one of the issues, I suppose, with problem solving is that it sometimes feels like a bit of an add-on to the curriculum. So I'm always looking for problems that I can integrate, and they're actually going to, it's not something separate to kind of what I'm doing in lessons. It's kind of integral to it. So that problem about the prison cells, you know, within that, you're talking about factors, you're talking about square numbers, and you're starting to kind of tick off, if you like, things that you're going to be teaching anyway, but hopefully you can teach them in a way that, I mean, I guess is more engaging, hopefully, but also developing that kind of problem solving approach as well. So the general rule here that I've got is this, you know, simplify and then look for a pattern. So on the next slide, if we go on to that one, just as another example of that one, I was going to see if this is harder. This is the show one. Although this does illustrate another point of the kind of, when you're doing problem solving type teaching, then actually giving them the answer is often quite a good strategy. Giving them something to work towards is often quite a useful approach, because I guess it's, you know, there's always that much more openness when you're doing problem solving, and so you don't want to close it down by guiding them through it, but you can close it down in some respects by giving them the answer. And obviously the other thing that this does is it emphasizes the importance of them kind of showing how they got to that answer. If you've looked at the new specification papers, you know, there isn't always, for the question, there isn't that kind of neat, here is where you need to put your answer. Actually, what they've got is they've got a box, and within that box, they've got to structure their structure their working and put their answer at the end and make sure that their answer is clear. And again, it's one of the other things I guess that we're hoping to achieve through these papers is that, you know, when they are completing these papers, they appreciate that. And I know this is something that we talk about all the time when we're teaching, about that idea that, you know, your working has got to be clear. But by taking away that answer line, it gives that responsibility back to the children a little bit more. Whereas if when you've always got, put your answer here, you know, it's very easy for them to kind of have a complete garbled mess of working and just to shove the answer in at the end. And really it then comes down to how it's been marked as to whether or not whether or not they're going to get the marks for working or not. So on the next slide there are some more examples. I'm not going to dwell on these. So I don't know if you've seen the answer in the chat. So yes, if you are registered, you do get a copy of the presentation slides. But there you will have these questions to look at and play with after the webinar is finished. Okay, so we go on to the next one. Okay, so my question then is, so the maths question is, after tennis, Andy collects twice as many balls as Roger and 5 more than Nadal. They collect 35 balls in total. How many balls does Andy collect? So my question to you isn't how many balls does Andy collect, but what's the problem-solving strategy that I'm hoping that this problem illustrates. I'll give it a second to see if anybody wants to throw any answers into the chat. But I'm already talking far too much, and I'm on about slide 4. Okay, if you go on to the next one. So, I mean, there are different ways, obviously, of doing that, and you can do a kind of trial and error and trial and improvement. Someone in the chat suggested using a bar model. The bar model is quite an interesting kind of step on the path to algebra. So, I definitely think using bar models to illustrate an unknown is a good step, kind of between whatever it is and what you might kind of term pure algebra, if you like. So Polly's suggestion is to introduce suitable notation, which in this context I would say is yes, it could be a bar model, and it could be algebra. And like I said, I think actually those two things are different versions of, essentially different versions of the same thing. Someone else says, Robert has put in, Andy equals X. So that idea of, maybe this comes up a little bit slower than kind of immediately. And the thing to me with algebra, so algebra is, it's a fairly fundamental problem solving strategy. The idea that you use algebra to represent some kind of unknown is a fundamental problem solving strategy. And obviously if they're going to be taking maths, past GCSE at some point, then it's going to be at the center of pretty much all the maths that they do. But I think, I guess what I would emphasize here is how it is introduced, and whether or not you're introducing algebra as kind of focusing on the grammar, if you like, of algebra rather than the purpose of algebra. And I would say that the purpose of algebra is to help people solve problems by you being able to represent and manipulate an unknown. But quite often it's a lot of the kind of exercises within maths textbooks, and at Key Stage 3 or Upper Key Stage 2 don't emphasize the use of algebra in that way. The tendency is for algebra within a textbook to be fairly, it's exercises that you're not ever getting close to that idea that algebra is about using you're using X or whatever it is to represent an unknown, and you can then manipulate that to try and find the answer. So if we go into the next slide, So then I guess for me then what's important is that when algebra is introduced in such a way that the children begin to think of it in those terms. So they think of it as a way of solving problems rather than just as something that they have to be able to kind of do the grammar with, if you see what I mean. So this one, you've got how many different ways can you find of calculating the number of squares in the border without counting them one by one? So you've got a 10 by 10 square there with the border shaded. And so what I would do is I'd give children the next slide, which is just lots of blank squares with borders, something like that, and tell them to use color to represent, to come up with different ways of counting those squares without counting them one by one. And if we go on to the next one, rather than there are quite a lot of different ways of doing it. And the point of this obviously is not how many squares are in the border. That's a trivial question, a fairly trivial question. The point is, can you come up with different ways of counting those squares? And if we go on to the next slide, so I think this takes us through different strategies that I think these are my year 7s at the start of the year. So this is this is basically my first week's teaching with year 7. And getting them to kind of represent and explain how they would count those squares without counting them one by one. So this is one example. If you go to the next slide, I mean, this is the extension problem, is when you start to think about rectangles rather than just thinking about squares and seeing how the situation changes. And you go to the next one, we've got just a couple more different. So again, a couple of different strategies that you could then use. Oh yeah, we'll stop there. And then my question to the children then is, first of all, can you summarize your strategy in a sentence, and then can you kind of simplify? Can you strip out that sentence so it kind of starts to look like an equation, and then can we take it a step further, and can we use algebra to kind of represent? So instead of saying number of squares in the border, you just say S, and we know that S means the number of squares in the border, and we know that L means the length of one side. And my approach here is, mathematicians are fundamentally lazy. They're looking for elegant solutions here, and how can we express this idea most elegantly? And we can do it most elegantly by kind of expressing it as what is hopefully a fairly simple equation. But the emphasis then is, the algebra has come from somewhere and it means something, and that kind of hopefully takes us kind of full circle into that. Algebra is there to represent an unknown. If you go on to the next one, sorry, we've got one more of those. This is again somebody's playing with it from my year 7s, and the next one after that. So this this problem comes from the U-Cubed website. The yellow circle isn't quite in the right place. It should be over the next one down, where it says mathematical mindset, teaching, and something, resources possibly, or maybe mathematical mindset. Oh no, it's the one above, mathematical mindset algebra. That's the one I'm looking at. So the U-Cubed website was developed by Jo Bowler, who I imagine quite a few have heard of. So she is at Stanford in California, and it was her team that put these resources together. And it is fundamentally about kind of teaching algebra in such a way that you're using it as a tool for solving problems, I suppose, rather than focusing too much on the grammar of it. And we will flick through. So there's a few. So the next one. So if you go on to that, there's a whole load of different problems essentially where you're using algebra, or you're you're working from a problem to kind of generate some algebra. I mean, you can do it in other ways, but it's a good way of introducing the idea that algebra can be used to represent an unknown. I mean, this this particular problem, the toothpick one, is interesting because I think as math teachers or as mathematicians, or I suppose you say kind of as older mathematicians, that there's the temptation to reduce everything to a sequence of numbers. So if this is pattern 3 has so many toothpicks, pattern 2 has so many toothpicks, pattern 1 has so many toothpicks, pattern 4 has so many toothpicks, and what you end up with is a sequence of numbers, and you end up looking for the formula, if you like, that links those sequence of numbers. But actually, with the best will in the world, there are very few children at the beginning of year 7 who are going to get to the formula for this particular pattern. It's 3n squared minus 2n or something. And I generally don't teach the quadratic sequences at the beginning of year 7. But actually, so if you go on to the next slide, and if you look at how the children break it down and kind of using visual representations, and then from that they can put the algebra together, which is on the right, just based on the patterns they're seeing and describing, and they suddenly come up with this 3n squared minus 2n, or some version of it, which they would never get by working directly from just from the kind of the bare numbers, if you like, from the sequence of numbers. And it's just, it's introducing algebra in a meaningful way, so that then they are then able to use it and manipulate it in a meaningful way when it comes to solving problems. So if we go on to the next one. Okay, so there's the next few are just kind of different examples from UCube. So that's one. There's I quite like this one. That's quite a nice one. And then the final one is also quite an interesting one, and an interesting one for them to try and simplify and to kind of grow as a sequence. So that's, and again, it's quite nice real life context within that as well, in terms of, that is essentially how steel cables are made, in terms of bringing together lots of smaller cables. Okay, so we go on to the next one. And lots of, so I guess this is what you're perhaps more likely to see in a 13 plus paper, in terms of the type of question where where the children are being asked to potentially use algebra as a tool to help them solve a problem, and working towards kind of an elegant strategy for solving problems by introducing algebra to represent an unknown. And we've done that as well with the 11 plus over recent years. I don't know if any of you use or look at the 11 plus papers, but there are sort of similar kind of questions that come up from time to time. Not necessarily expecting children to use algebra, but I think if you're, it's useful to kind of look at the ways that children are approaching those problems and seeing what strategies they use. But yeah, this kind of thing, I guess, is what they might encounter more in a 13 plus paper, kind of moving down the line. And again, it's that the question is, it doesn't take a lot of words to describe it necessarily, but then they've got a choice of how they then solve what would then be a 4-mark question, or something like this would probably be a 4-mark question. Okay, if we go on to the next one. I should just say on that point, so one of the things that we try to do with the papers is to, essentially to kind of have slightly fewer questions and give more marks. It always gets it's always gets slightly tricky when you're writing the mark schemes for these, because you don't want to be too prescriptive, but sometimes the feedback we get from people is that they want more guidance from the mark scheme. And actually, I guess what we're moving towards is, this is a 4-mark question and you've got 3 method marks for some kind of sensible method. And we don't want to say, well, the method is this. You go through these these 3 steps and then you get the answer at the end. We want to say, well, we've got you know, there are 3 marks available for the method they've used. And, you know, you've got to, if you're marking the papers, you've got to use your own judgment about whether or not they are deserving of their marks. And it does, I fully appreciate that, introduces some kind of, there's space there then for kind of interpretation and subjectivity. And, you know, the reality is that has always existed in plenty of subjects, whether it's English or history or, even in the other subjects for scholarship papers. And the reality is that there isn't a, you know, if you're still sending CE papers off to senior schools to mark, you know, you never know exactly how they're marked and what marks are given for what, and you will know that there's not necessarily consistency in the way that papers are graded by senior schools. So just a few more examples of algebraic question. And then these ones specifically, so the same thing, but specifically taken from UKMT maths challenges, from various different maths challenges, whether it's the junior maths challenge or the junior Olympiad or the teen maths challenge. It's a pretty good resource to mine. And if you're not aware of it already, there is a website, if you go on to the next slide, called Diagnostic Questions, that allows you to pick out UKMT questions by theme. So you can look at the junior theme questions or the intermediate theme questions. So rather than just having a mixture of question types, you can practice solving a particular kind of question, whether it's angles or arithmetic or percentages or whatever it is. But there, the UKMT are a pretty rich resource of problem solving type questions rather than, you know, what you might call basic maths questions. Okay, if we go on to the next slide. Okay, a goat is tethered by a 6-meter rope to the outside corner of a shed measuring 4 meters by 5 meters in a grassy field. What area of grass can the goat graze? So my question again is, what is the problem-solving strategy that you are hoping that a child in your class would use when given this problem? What headline approach, I guess, would we want them to adopt? How would we describe the strategy that they might be using? And we'll give it a few seconds to see if anybody throws anything into the chat. And I think the chat might come up slightly later than you type it in for me. I'm not sure. Oh no, it doesn't. Amy Dunn, draw a diagram. Yes, exactly. If we go to the next slide. There you go, draw a figure, is what Polya says. So yeah, some kind of way of visualizing the problem. And this then is not, and it takes it back to that that starting point. You know, sometimes you're stuck because you don't know what to do, and sometimes you're stuck because you can't see the problem or understand the problem. And sometimes in order to be able to understand the problem, you've got to represent it in a way that makes it more apparent what you have to do. And yeah, a lot of the time, the best thing to do is to draw something. And yes, it can be bar models, but actually there will be a lot of situations where a bar model is not the right thing to do, but some kind of diagram is what is needed. And as with all of this, it's about giving the children experience of different problems and different strategies, so that they begin to learn for themselves which one it is they're going to pick. So having some kind of display up in the classroom that basically says, these are our strategies. You can simplify it, you can draw a diagram, you can introduce algebra. So when they're given that, when I give them that goat problem, and I say, well, choose which of those things, and they're sitting there going, well, I'm not sure where do I start? And I said, well, look at that list of kind of problem-solving strategies that are on the board, on the wall over there. Which of those are you picking? And again, usually at that point they kind of go for the right one. So if we go on to the next slide. So again, a whole selection of problems, I suppose, where they're being asked to to visualize the problem, or where, you know, a diagram of some description is likely to help them in some way. And some of these are quite interesting when you give them to your classes to solve. One of the things that I find is that, you know, a lot of the time it's the, if you like, the less confident mathematicians who are more inclined to use some kind of diagram to help them. And so that top left one, walking up a steep hill, I pass 10 equally spaced street lamps. I take 5 seconds to walk from the first to the second, 6 from the second to the third, and so on, with each time increasing 1 second as I slow down. And invariably, whenever I've given that problem out, the people who draw a diagram get it right, and the people who don't draw a diagram get it wrong. And it's fairly clear cut. But quite often it's, like I said, it's the slightly less confident mathematicians, perhaps, if that's an appropriate way of describing them, that tend to draw the diagram. And, you know, it's the more confident mathematicians who, I can do that, that's easy, who don't draw the diagram and then get it wrong. It's no bad thing, because essentially it helps the slightly more confident mathematicians to realize that actually the drawing a diagram is not a, you know, it's not something that's, it isn't just kind of bar rules for year 5 or whatever it might be. It's something that you would expect mathematicians to use throughout their career. And especially if you then go into, you know, different ways of working, there are plenty of mathematicians out there who would say that, you know, Einstein thought in pictures. There was a lady who was a mathematician at Stanford who won the Fields Medal a few years ago, and sadly died in her early 40s, but all of her maths was kind of based around visual representations of things, not just kind of lots and lots of numbers. Okay, if we go on to the next one. Okay, so this is, I mean, if it takes 2 minutes to fill a bath using just the cold tap and 3 minutes using just the hot tap, how long would it take to fill the bath with both taps on? So the strategy that sits behind this, I mean, I'm not going to ask you to guess this one because it's probably not very clear what I'm getting at from this question. So if we go to the next slide, one of Polya's suggests, could you think of other data appropriate to determine the unknown? Which I have kind of twisted into pick a number. So that bath problem, actually, if you give the bath a volume and start working with kind of real numbers, if you like, rather than the abstract problem, it becomes a lot easier to solve. And, you know, there is an elegance to solving it without kind of picking numbers, but actually you need a step to get there. And actually the easiest way to start is to say, well, this bath has got a capacity of 60 litres or, you know, 360 litres, whatever you want to pick. Although it does help for the children to learn that, you know, if it's 2 minutes and 3 minutes, then picking 100 litres is not going to help them particularly. Well, certainly not going to make it easy, whereas picking 60 litres would make it easier, even though that might be quite a shallow bath. So if you go on to the next slide. And there are certain kinds of question that this method, I guess, suits or applies to. Speed questions and percentage questions, where you're not given. We'll take the top right. A shop reduces the price of a bike by 20%. A week later, the bike has still not been sold, so the shop takes 30% off the new price. So you're not given the price. And yes, you can work it out by kind of multiplying your percentages. But if you're doing this at the beginning of year 8 or end of year 7 or whatever, they might not be there yet. And actually, this becomes a very simple problem to solve if you start by saying, well, the bike originally cost £100, and now work out what percentage it has been reduced by. So that idea, again, it's that list on the wall of which of these strategies is going to help. And, you know, for this question, you know, once that strategy is there in front of them, they're going to go, oh yeah, I'm probably not going to draw this, but I could just pick a number. And because it's percentages, maybe the number to pick would be 100. But yeah, some more examples there. And again, like this kind of comes back to this, you know, how you integrate these strategies into the curriculum. This is a strategy that, yes, it would be explicitly taught, or I would explicitly teach it when we're looking at percentages or when we're looking at speed. Because I know it's a strategy that going to work well for those problems. Okay, if we go on to the next one. And another type of question where I know this comes up quite a lot. So the more advanced geometry questions, where so you've got two circles here, and it doesn't tell you, it doesn't give you a radius for the circle. It just says what fraction of the area of the larger circle is outside the smaller circle. So you pick a radius of 1, whether it's for the pick a radius of 1 for the small circle and work from there, because it's easy to work with. But with the advanced geometry questions, quite often they don't, or sometimes they won't give you a number. So it gives you something to work with. Okay, last one. I'm slightly behind time, but I'll keep on going. And then the final, I guess the final, in some ways, the most important thing is this. So one of the strategies that Polly suggests is this kind of, have you seen it before? And one of the, if you speak to people who who solve maths problems, or who are quite good at things like the UKMT type papers, that's because a lot of the time they've just done lots of those problems before, and they get to know it, and they get to kind of get a feel for it. And so one of the things, and it's just that point that you have to have practice of some problem solving in order to be able to do it. It sounds slightly daft to say it because it's fairly obvious. The question that does come up about is kind of, do these questions appear on the core or the additional? I mean, it depends on the level of the question. Some of those algebra questions would very easily sit in the core paper. That circle question that I just showed you, I probably wouldn't expect to appear until a scholarship paper. I think the point that I guess ISEB want to get to is that all children are taught problem-solving strategies, regardless of whether or not they're working towards a foundation paper or a core paper or the ad maths paper or the scholarship paper. Hopefully there'll be scope within all of those papers for something that might look like more like a problem-solving question in which they get stuck. Next, what's the next slide? So a couple of examples of when you know the trick. I mean, it's not really knowing a trick, but when you so interestingly, I will just address the question that's come up. It's not about the whole paper. What we're trying to achieve, I guess, and I can't remember if we kind of went, if there was a percentage, it might be something that we can follow up with. The idea isn't that. So if you're looking at the core papers, it won't be the whole paper that is written this way, but it will be a certain proportion of every paper is kind of geared more towards problem-solving questions. So if you look at the specification papers that have already been published, what you will hopefully see is that there's kind of a first half that is kind of practicing core skills, if you like, and then there is a second half which is more towards problem-solving papers. And that's what we wanted to, I suppose that was one of the main aims, was that you'd have a half a paper which will be, these are the fundamental skills that you need that will enable you to take you forwards into kind of senior school maths, if you like. And then there will be the problem-solving questions are, it's still those skills, but it's a different set of skills. I mean, so we're hoping to test those two sets of skills side by side. Have you mastered the basics of number and algebra, essentially, in the first half of the paper, and a few other bits of geometry too? And in the second half, are you beginning to master some problem-solving strategies which will enable you to kind of go forward with GCSE maths as well? The question, will there be problem-solving questions on the foundation paper? I mean, yes, it would still be broken up in the same way, with the first half of the paper on skills, but, they will be, I guess, simpler problem-solving questions rather than the same as you'd necessarily get in the level in the core paper. And it's worth saying that one of the other intentions with the changes to the paper was that the foundation paper would be sat by fewer pupils than currently sit the level 1 paper. And we were slightly Yeah, there are foundation papers that sit alongside the core papers. Oh, I don't know. Maybe we can pull those up in a minute. But there is a foundation paper too. But yeah, as I was saying, fewer children will sit. The idea is that fewer children will sit the foundation paper than sitting the core paper. I mean, the intention, it's an inexact science, obviously, but the intention was that we would want the majority, by which we meant 95%. Ideally 90 or 95%, to be able to get 50% or above on a core maths paper. I mean, that's very broadly what we were aiming for. It's, like I said, it's an inexact science, but that was one of our starting points. We wanted 95% of the people who sat the core papers to be able to get 50% or more. And of those 95%, you're talking about quite a large percentage who would actually score very highly, the 80s and the 90s. And who would then go on and sit the ad maths paper. And they might sit the ad maths paper and only get 40%, or they might get 30%, but actually, well, let's say 40%, but actually getting to that point that actually on an ad maths paper, that is a respectable score. You've got 87% on a core maths paper, you're going to have a go at an ad maths paper and you're going to get 47%, and actually you can be pleased with that rather than looking at that as not being successful. I'm not sure about the textbooks. Somebody at ICB might be able to answer that. I think I'm nearly at the end of my slides, so we'll skip ahead and see what we come back to. So a couple of things. So coming back to that point about what you do when you're stuck, it's quite useful to find problems that kind of don't make you get stuck, but well, let's go on to the next problem and I can explain what I'm talking about. The next slide. So this one, for example, and I appreciate it's a 7 to 11 question, but actually, it's a good year 6 question. It's a good year 7 question, because it's so well defined that this could be a kind of problem solving question that you might see on a foundation paper rather than on a core paper. And it's very contained, and you might have to spend some time battling with it, but actually most of them will get there eventually, and hopefully they'll kind of develop strategies in terms of thinking about which numbers are going to divide and which numbers aren't going to divide. And for this one, it's really about figuring out where to start. If we go on to the next one, and actually if you're looking at kind of developing that idea of what to do when you get stuck, then the Enricher website has a whole load of stuff on being resilient, and it's obviously a fairly good place to start when you're looking at looking at children getting better at being stuck and not panicking when they're stuck, and not just automatically asking for help when they're stuck. And that's one of the hardest things to kind of to get past, I suppose. I would just address the question that's come up while it's there. So, which is the additional paper equivalent to the current level 3 for CE? No, not exactly. It's likely to be harder. One of the things with the level 3, but it's harder in a different way. I suppose, again, it comes back to that idea of the kind of the questions being slightly contrived within the old CE papers. And actually what happened with the level 3 is they just kind of became a bit more contrived. And I suppose what we're hoping to achieve with the ad maths paper is that there will be more problem solving. So it won't just be sort of harder numbers, but the same skills. It will be more about testing the problem solving skills than just kind of doing the same thing, but with decimals instead of whole numbers, which is sometimes what the level 3 papers felt like. If you go on to the next slide, I'll rattle through the rest. This comes back to my original point about, it was once claimed there are 204 squares on a chessboard. Can you justify this claim? You're giving them the answer. It is less intimidating as a 12-year-old, 13-year-old to know what you're aiming for. And, the question on the right, you've got the parameters are defined, and actually one of the skills that you want them to develop is, it is that kind of rucksack thing of checking the answer at the end. Once they've done that question about the number of lizards, beetles, and worms that Ross has, it says that there are 12 heads and 26 legs. So when they have got what they think is an answer, does their answer have 12 heads and 26 legs? And so a big part of teaching problem solving is about teaching them to kind of feel confident in when they have got the right answer, and not just having to kind of say, is this correct? But actually being able to kind of evaluate for themselves whether or not the answer is right by looking back at the question. And you can use certain problems to help you develop that skill, such as this one. Whereas, when they say, is this correct? Would say, well, this is what the question says. Does your answer match the question? And they can hopefully evaluate that for themselves. If we go on to the next one. So to finish, I just wanted to share, I guess, one more website that you may find interesting if you're not already familiar with it. So it's a blog by a guy called Don Stewart. The blog is called Median. So he was a maths teacher who very sadly died a couple of years ago from COVID. But over the course of his career, he'd just put together this incredible resource bank on his blog. And essentially what sets these questions apart is it's just a slightly different way of looking at what you might think of as kind of normal maths, if you like. So rather than kind of standard questions, he kind of takes what might be a standard question and turns it on its head a little bit. And this then feeds into that idea of that problem solving thing of being confronted by something unfamiliar and not being intimidated by it. So if they're used to seeing unfamiliar things, and I appreciate that means they then start to become familiar, but that's kind of the point. Then they won't be kind of intimidated by unfamiliar things, either in an exam or, further ahead when they move on to senior school. Just because, they've seen lots of, can you find a percentage of this question? Great, they know how to do it. But what if that question is spun around a little bit? Can they still do it? Well, they will be able to if they know that, if they've realized that they've seen those kind of questions before, where it's not exactly as it might be. Right, so we're going to rattle through these fairly quickly. So the next one, different ways of looking at equations. So rather than solving the equation, so the point here is not to solve the equation, it's to look at the relationship between the equations. So if you know that h plus 17 equals 53, you know that h plus 7 equals 43, but not because you worked out what the value of h is. So lots of questions like that. Next one. And obviously you can peruse these more at your leisure, if you like, once the webinar is finished. So a cover up, a different technique for solving equations. It's that first one, 13 take away what equals 9. So you know that n minus 6 is 4, and then you work that way, rather than, again, solving it in a, I suppose, a traditional way. Next one. Okay, so we can flick through these. So there's a few problems on, angles in polygons, but, not just kind of typical angles in polygons. So here's a decagon, and we're going to fill it with a variety of different polygons. And can you work through those kind of unfamiliar ones? The next one, if we go to the next slide. So again, rather than giving a set of numbers and saying what's the mean, what's the modian, what's the median, working backwards from that. Next one. So on averages again, but again, just looking at it from a slightly different way and kind of, how do we change the mean? What effect does that have on the mean? Next slide. Similar again. I obviously like these ones. Next one. Yeah, some different things with circles. So not just here is a circle, some different circles, and similar again, just looking at things in a slightly different way, or some proof takes it a bit further. And then some, yeah, again, looking at fractions, but not just kind of giving fraction additions, but 4 fraction sums that add up to 23 over 24 with neither of the denominators being 24. So you're still practicing adding fractions, obviously. And then this is more about a way of introducing fraction division, which is quite interesting if you want to look at it. But we'll carry on for now. Again, it's turning the context on its head. So what's the rather than saying what's the highest common factor and lowest common multiple. You know, these are the highest common factors and lowest common multiples. What's the numbers? Next. Yeah, I think it's fairly self-explanatory, that one, but just kind of working through it. And again, kind of working from one percentage to another, rather than kind of just what is the percentage of, what is X percent of Y. Well, I had this on here just to kind of, I always get, I don't know if this is just me, but I always get kind of slightly wound up by the fact that it doesn't seem to matter what school I teach in. So the physics paper for common entrance, the speed question is always really easy. So they always just throw them into the triangle and it works perfectly every time. And then they try and do the same thing in maths and it doesn't work at all because the numbers are harder. And actually a lot of the time they try and throw it into an equation when they really don't have to. And you kind of have to train them, or I have to train them to not just use the formula and just to use common sense. And actually, you know, common sense will get them a long way a lot of the time in maths. A peregrine falcon flies 14 miles in 15 minutes. What is the average speed in miles per hour? You don't need a triangle, you just need to times by 4. And actually they can, you know, they really can do that. But you do have to train them not to use triangles and fight against your science department who will try and get them to put everything in a triangle. But these questions are from, and these questions are a good way of kind of building that confidence of, actually, you can do this without triangles, you can just use common sense. Next one. And this comes back to the original strategies, but these are just more questions from the Don Stewart website. And then the final two, again, are just variations on a theme. So rather than just kind of, you know, that practicing of those standard transformations questions, you know, there are different ways of looking at it and different ways of approaching it. And the final one, again, is another example of that, where you've got a series of transformations to do that builds a nice little shape in the middle once they've done all of their different transformations. But it's a good, I mean, there's masses on the Median website. And it takes a little while to kind of find your way through it and find, because it is a secondary resource, so it does go all the way up to GCSE and A level. So you do have to kind of pick out the stuff that's more appropriate for Key Stage 3, for Year 7 and 8. So I mean, you'll get the you will get the resources, and it is on there, but it's called Median, and it's Don Stewart. So if you search for Don Stewart blog or Median, you will find it. And I found it, I don't know, 2 or 3 years ago, maybe more than that now, 4 years ago, and it sort of changed all my. I suddenly had this incredible selection of resources that kind of made the children look at things in a different way, which was exactly what I wanted. And I just never had the time to generate those resources myself. And it's like, oh, someone's just done it all for me. This is incredible. And yeah, it probably now makes up, you know, something like, well, maybe not quite 50%, but somewhere between 25 and 50% of my teaching now relies heavily on these resources, which I hadn't found for the first however many years I was teaching maths for. Okay, I'm over time. I apologise, but I think we are going to spend some time going through some questions now. Hopefully that has been helpful. It was kind of a slightly whistle-stop tour. I did say I was going to overrun, but I'll stop talking now. We can do some questions.
Thanks so much, Paul. That was brilliant. Lilia, has just asked, please kindly repeat the website you just mentioned.
Yeah, so that's Don Stewart, and it's Median. Actually, if I type it, I assume I can type into this chat too.
If you type it in there, I can put it into the YouTube chat for everybody now, actually. If you just put it into ours, I'll make sure I pass that across for you. Okay,
I'll put in the URL. That's probably the easiest thing to do. Wait for some more questions to come.
And Lelia has also asked, can we assume that there are fewer questions within the same time limit in order for the pupils to be able to complete them?
Yeah, and actually, so one of the ways that we went about achieving that was to basically give more marks per question. So yes, there will be fewer questions, and yeah, and those questions will be worth more marks. So it's still 100 marks, but hopefully what you'll see is that marks are worth more than they used to be within the within the old papers.
Perfect. And Lynn Wilson also asked if the, and I'm paraphrasing the beginning of your question, Lynn, but I hope this is right and what you hate to ask. At the time we were talking about the equivalency of the additional paper to the previous level 3. And so after that, Lynn had asked, so if that's difficult in a different way, then what is the level for case?
So, I mean, Julia might be able to tell me this. My understanding is that case is sort of still to be reviewed.
Yes, that's right.
Essentially. So it is something that, you know, ICB are aware it's kind of next on the list, I think. So at the moment it's, I mean, inevitably there is always going to be some overlap. There's always going to be overlap between foundation and core, and then core and the AdMaths, and then the AdMaths and the scholarship. So they do kind of blur together. That's always going to always be the way. But I guess with the case, what we would be looking for is that same kind of approach. I mean, one of the things that, if you're familiar with the case papers, they were, especially section B, incredibly wordy, sometimes huge amounts of text. And actually, if we can get closer to something where we kind of strip away a lot of those words and just give elegant mathematical problems, and then give the children space to kind of answer them in their own way, rather than that kind of lots of words, lots of scaffolding. A couple of the ones coming through. So what happens in terms of marks if there are missing units? So what you'll see in the mark scheme, so if it's a 3-mark question, you'll have, for example, one mark for method, 1 mark for the answer in terms of the numerical answer, and then you'll have another mark for the units. So if they give the incorrect units, there would be the expectation that they would lose a mark for giving the incorrect units. It's taken early next year's timeline for sending a specimen.
Referring to case and the specimen, what I'll do, Lynn, is I will have a look because the new papers, the new specification papers, are the foundation, core and additional. Case has not had a specification update, and so those papers will be written in much the same way, which means that any practice papers or specimen papers for case that you have within your school, those will continue to be absolutely valid and relevant. And what I'll do, Lynn, is I'll have a look at the website in a moment and just double check that those specimen papers are up there and where they are for you. Paul, we had some questions coming ahead of time from people who wanted these addressed as they booked. And so I'm just going to find those. The first one of these says, how do we cater for different levels? And what they were alluding to specifically, that is low-level ones.
So I mean, so this comes back to the point I was making earlier, I suppose, about, you know, what we're hoping is that some of those children who did take, or who historically would have taken level 1, will now be able to access the core papers. I suppose what we're hoping is that there's a smaller minority who are taking what will now be the foundation paper, and so the foundation paper is, if you like, written to reflect that, you know, that it's catering for quite a small group of pupils now, rather than being slightly broader, and so hopefully you'll see that within that foundation paper, that you can prepare, if you like, more specifically for that paper than the core paper. I mean, again, taking it even more broadly, one of the changes which you'll probably be familiar with is that actually a lot of the content is stripped out. I mean, not a lot, but there was some topics are taken away, and one of the things we tried to take away were kind of, you know, the slightly time-consuming topics, which we felt could probably be taught fairly quickly later on, but for us, we're taking quite a lot of things like bearings coming out to kind of facilitate that as well. I don't know if that answers that. I hope it does.
Hopefully it does. I've got another one here that says, am I correct that the scholars do all the foundation papers and the additional paper?
So probably not the scholar. I mean, the scholars, you would anticipate just doing the case paper still. I mean, if they're this is one of those impossible to answer questions, because it depends on the school they're going to, and what the requirements of that particular school are. But so and the additional paper. So your higher level mathematicians who are not doing scholarship, yes, you'd very much expect them to do the core and the AdMaths paper. And the feeling was that if they were the kind of child who could access the add maths paper, then they wouldn't mind doing basically another maths paper because they'd probably quite enjoy it. So yes, it does mean if you're doing the add maths paper, you're doing the 2 core papers, the non-calculation and the calculator core paper, and then you're doing another paper on top of that. So you are doing 3 papers. But I think the hope was that those children who would fall into that category would probably quite enjoy it and not mind at all.
Thank you very much. Well, given that we are at about 6:10 and Paul has given us so much rich material, I think it's time to just say thank you very much. Oh, a very quick one has come in from Lelia, which says, where can we access a list of topics you are removing from courses?
So on the ISEB website, there is a page. I don't know if I put this into the
oh, thank you. I'll send that over.
And you can copy it straight across. There is a page on the ISEB website, and on that page, so it's the CE Mathematics page, and at the bottom or halfway down that, there's a page called Documentation and Resources, and one of those resources is New Mathematics CE specification, what's in, what's out, and hopefully that has everything you need. The question is, there's still a mental maths paper? Yes, there is, but it is different. So it's no longer a recording, it is a written paper. So it's a 10-minute paper with 40 questions. But it's a written paper rather than a recording that they have to listen to. And that the focus of that is very much on kind of fluency with different strategies. So what we try to include within that is it's the kind of questions that are going to hopefully test in a good way their awareness of efficient strategies when working with numbers, and hopefully you'll be able to see that if you when you start looking at some of the papers.
Fantastic. Lelia says mental maths paper for all levels.
Yes, essentially. So it's one paper. If you look at and again, I guess that the hope would be that actually so I think some people have commented that it looks quite easy. I think our idea is, we want the children to be successful at it. So we want them to, we don't necessarily want them to find it easy, but we do want them to feel that they can do it and they can achieve well in it. So the first 10 questions are just times table questions, and then it's kind of a gradual progression. The next 10 are fairly basic arithmetic, I suppose I would say, sort of 2-digit plus 2-digit, or a division question rather than a multiplication, or instead of 6 times 7, 60 times 7. So they get gradually harder, and you would hope that the level 1, the foundation candidates will be getting around 50%, and actually the reality is if you're doing add maths you'll probably get 100%, and that's great.
Is the additional paper staying at the same level as the specimen, as we think it's very challenging? And Amy's also asking for some more specimen materials. Paul and I will go away and discuss that one, Amy. But in terms of additional paper at the same level, what do we think?
I mean, yes, there or thereabouts. I mean, it is supposed to be, I suppose, harder in some respects than the level 3, and it is that idea that I guess one of the reasons for getting them to do the core maths and the add maths rather than just the add maths in isolation is that thing I was saying before, is that the idea is that if you get 85% on the core maths and then you get 40% on the add maths, then that is still an achievement, and a good achievement. So it does involve reframing with the children kind of what success looks like, and within that add maths paper, I guess it needs to become clear that actually if you have got 30% or 40%, then that is still a respectable score, and putting 30% on top of your 85% in the core maths is something that you can be proud of. But I appreciate there's a narrative journey there that the children are going to have to go on to kind of understand that change.
Great. Lots of calls for further specimen resources, so Paul and I can go away and talk about that and make sure that we're supporting people properly. I think there's just time for one more, which was from Miss C. Moss, and she's asked what proportion of the overall mark comes from the mental maths paper.
So the mental maths is out of 40, So and each of the core papers are out of 100, or each of the foundation papers are out of 100. So it's essentially 40 out of 240. I'll let you work out the percentage.
Well, it is a problem-solving session, Paul, so leaving everybody with a little bit of maths is lovely. Helen has said, oh, thank you, really useful. It's going to be so much more interesting teaching and learning in year 8 now. She's looking forward to those changes. And Rachel Clough has also said the new papers fit much better with a mastery teaching approach. Thank you. Lelia has less convinced. She says, I think it would take a lot to convince children that it's good to get 30 or 40% in that additional paper. But she also says, thanks so much for all your help. Amazing, in capital letters, which is wonderful to hear. What I'd love to do is thank all of you who have joined us this evening for some utterly brilliant comments. You're clearly really, really engaged with not only what you're teaching, but the changes to CE. And I know that Paul and I, and also with Patrick as well, the lead setter for maths, will go away and have a think about all of the things we can do to help you. We know that one of the challenges for ISEB, and one of the things we're absolutely committed to doing, is producing lots of resources. And Paul might want to shut his ears at this point, on more CPD sessions, because what we find is when we get to engage with you like this, we learn more about what you need, and you can also get further under the bonnet of what these papers are about and how you can support your pupils better. So thank you, Amy. Useful session. Thank you for this evening. Thank you all. Thanks, Athena. That's very kind of you. Excited by helpful problem-solving tips. So it looks, Paul, as if you've given everybody an awful lot of great tips to think about, which was the whole aim of this session. A huge thank you to you for joining us. And Paul, as ever, wonderful, thought-provoking, exciting session. And we look forward to seeing everybody again soon. Take care.
Thanks.